Hey, Algebra 2 and Honors Algebra 2 students, I'm back. This is Mrs. Felon. We are on page 31 of your student journals. We're going to talk about lesson 2.2. So page 31, student journals. All right, so now we're getting more into our conversation about quadratics. So the first thing that we're going to ask you to kind of identify is some terms that we're going to kind of be using quite frequently. The first one is the axis of symmetry. I'm just going to draw a quadratic graph over here. So just a sketch, nothing too fancy. So this would be my parent function, like a normal looking parabola. An axis of symmetry, and sometimes it's easier to kind of see it than it is to kind of write it in words. An axis of symmetry is basically a line of symmetry. And so it is a vertical line that divides your parabola in half. What I want you to get out of this is obviously understand where the axis of symmetry is on a graph. So it goes, but other thing I want you to know is that it always passes through the vertex because it has to cut this in half, which means this bottom part here is my vertex, and we'll call it H comma K. That means my axis of symmetry is a vertical line that passes through the vertex. Here's the big thing, and this is more of a pet peeve for me, is that you make sure you label it correctly. Because it's a vertical line, think about what the equation of a vertical line would be. It has to be x equals, has to, because it's a vertical line. And so because it passes through that vertex, it's always going to be x equals the h value of your vertex. So if your vertex, in this case, mine's at 0, 0, then this line would be x equals 0. If the vertex were over here at 5, 0, then my axis of symmetry would be x equals 5. It's always passing through that x value of your vertex. So h value, because we call the x value of your vertex the h. All right, standard form. We talked about this in the last video a little bit, but standard form looks like a equals ax squared plus bx plus c. So you probably learned this a lot when you're talking about quadratic formula, negative b plus or minus square root of and so forth and so on. All those a's and b's and c's pertain to the numbers in your standard form equation. So the a is always the number when in standard form. A is always your number in front of x squared. B is always the number in front of x. C stands for your constant term. This a value still is kind of the same deal as in like a vertex form where the a controls whether it opens up and down and vertical stretches and shrinks. It's just not quite the same properties, but we'll get into that in a minute. All right, minimum. So a minimum occurs when your parabola opens up. So in other words, when your a value is greater than 0, because in order for your parabola to have a minimum, and I'm just going to draw a different one, not a parent function. What we're referring to here is that this is the minimum point of my graph. So when you have a minimum, that means your parabola is open up. Well, if your parabola opens up, it means that a value has to be positive, which means the a value is greater than 0. What I need you to get out of this is that you understand that a minimum happens when the parabola opens up. A maximum happens when the parabola opens down. So that would be kind of the other scenario, right? And this would be a maximum point because that's the highest point, whereas this is a minimum point, which is the lowest point. The other thing I want you to get out of this is understanding what I'm asking for when I ask you for the minimum value or the maximum value. By the way, this means a is greater than 0. All right, so we're kind of referring to the absolute value of a here. I should probably put that in there. All right, so when I ask you for the minimum value, what I'm referring to here is basically the distance on the y-axis. So I'm asking like how high up is your parabola, or how far down, I guess you could say. So an easy way of knowing this or remembering this, it's the y value of your vertex. And this works for both mins and maxes. It's your y value of your vertex. So if my vertex were, let's say this is the point, 2, 1, I would have a minimum value of 1. So you would not call it a point, you would not call it a line like your axis symmetry, you would literally call it 1. It's a distance. If your max here was -1, 6, and you would say the max of this lovely function is 6. So again, it's kind of like your distance on your y-axis. That's how you're going to describe it. All right, last kind of term for this little part is intercept form. We talked about that in the first video. It looks like this. We introduced P's and Q's. Nothing too strenuous here. We just didn't know what other letters to use, so we use P's and Q's. Basically, this is like factored form, I want to call it that. So the A value still out in front, still does the same thing as the A value always does, but x minus q is what we call intercept form. So just in case you need an example of that, let me show you an example over here. This is what we call intercept or factored form. So sometimes you'll see me call this factored form. I'm sure your other teachers will as well. So just in case you hear it, just kind of note that that means the same thing as intercept form. So what they're getting at here is why this is called intercept form is because the intercepts are easy to figure out. So the x-intercepts, in fact, are easy to figure out. If it's already factored for you like this is, all you would do is set each of those factors equal to 0 and solve for x. So what you find here, like 2 and -3, those are what we have as our intercepts, or our x-intercepts, to be more exact. And so on your graph, this means the parabola is going to cross the x-axis at +2 and -3 for this example. So we call this intercept or factored form because the intercepts are really easy to find. All right, so now we go into kind of like a breakdown of each format of your quadratic. There are 3 forms of a quadratic: standard, vertex, and intercept form. I'm going to grab a separate sheet of paper. You may want to, just because there's not a whole lot of room on the sheet. I'm just going to kind of hit some highlights of each individual form. That way you can kind of take some notes about what's special about each form. So if you want to grab a sheet of paper, pause the video, go grab that now. All right, standard form. So standard form, if you remember, was that formula ax squared plus bx plus c. So what's fancy about standard form? There's a couple good things about standard form. Number one, the y-intercept is very easy to find. Your y-intercept is kind of given to you. So that's what kind of each format kind of gives you a piece of information about your graph. The standard form gives you the y-intercept. It is always your c value. So how we write that is, as an intercept, of course, is 0, comma, c. So the y-intercept is your c value of your equation. So I always write that down as kind of something that you're given. You also need to know, in order to be able to graph a function that's in standard form, you need to be able to figure out where the vertex is. So you probably learned this before, but there's a formula to figure out the vertex. And it goes like this: -b over 2a. And what this is, this gives you the x value of your vertex. So this provides you with the x value of your vertex. And so what you're doing here is whatever this number is here, -b divided by 2 times a, gives you the x value. Once you know your x value, then you plug in your x value back into your equation to get the y value. So remember, a vertex is the point h and k, right? So you need to get the x value, you need to get the y value. So this is the formula we use to get the x value. Once you know that number, plug it back into your equation, solve for y, and that'll give you your y value of your vertex. So I'm going to mention this, how we find our x-intercepts. So the easiest way to find the x-intercepts is to factor. We'll go over a lot more of this, more in the next we do 2 units on quadratics, and that's what we kind of hit in the second unit. But basically, you're going to factor your equation, like get it into factored form or intercept form, and then solve like I did on the previous page. So if that doesn't work, remember, you always have the quadratic formula. And I will go over that again when we get there. But basically, those are 2 ways in which you're going to find your x-intercepts. So we also call this solving, incidentally. So those are kind of the highlights of a standard form equation. So the main points here that we're going to kind of, when we have to graph something, we definitely need the vertex. It would be helpful to know where it crosses the x-axis. And then of course, if we could find another point like the y-intercept, then we can always reflect it and get another point on our graph. So that's what we get for standard form of our equation. All right, I'm going to go with, now let's chat about intercept form. We've already kind of done vertex form, but I can kind of go over that if we need to. So remember, this was our intercept form, A and then x minus p, and then x minus q. All right, so the easiest thing to find here are our x-intercepts. So you just go x minus p equals 0. So, and then x minus q equals 0. And then you'd solve for x. So x equals p, so your x-intercept would be at the point p0, x equals q, your other x-intercept would be at the point q0. So that's the easy thing. That's what this format kind of gives us. It kind of gives us a piece of information. That one's easy to figure out. All right, next thing, vertex. Very important, lovely point of our graph. The easiest way to do this is if you've already figured out your x-intercepts. So think about this. Here's your parabola, right? Let's say you know this is at, 6, 0. And let's say you know this is at -4, 0. Well, think about what it means to have the vertex of your graph, right? The vertex of your function needs to be symmetric, right? It needs to be halfway in between. So it needs to be like right here. So an easy way to figure out the vertex once you already know your x-intercepts is to average, like what's halfway between -4 and 6. So algebraically, what you would do is you'd average your x's. So you add -4 and 6 together, you get 2, and then to average, you divide the total, which in this case is 2 points. So I figured out that the halfway point is at when my x value is 1. So again, all I really did is plot my x-intercepts and figured out what was halfway in between them. So from 1, if this is 1, 1 to 6 is a distance of 5. From 1 to -4 is a distance of 5. I knew that vertex had to lie right smack dab in the middle. So what I would call for directions, if you want to write this in words, would say find x-intercepts, and then halfway between will be the x value of your vertex. So halfway in between your two x-intercepts is the x value of your vertex. And then of course, because you need to get a vertex, you need that y value. Last step is plug in x to get y. So go back to your original equation. Once you know that this is 1, for example, you'd go back to your equation, plug in 1 in for x, solve for y. And that's how you figure out the vertex of your function. I'm just going to kind of go over this one just because we mentioned it on the other one, the y-intercept. This is really kind of found more algebraically. And so for the y-intercept for a factored form equation or intercept form equation, all you're going to do is plug 0 in for x and solve for y. Remember, a y-intercept is always 0, comma, and then a number, right? And so it makes sense that if we could plug 0 in for x, that would give us our y-intercept, because it's always when it's always when x is 0. So those are the two new forms, other than the vertex form that we've talked about real specifically in the last units. The only other thing I want to talk about is domain and range, and I'm going to add on this here. I talked about this in class, but again, domain and range, just as a recap. If you have a function, any quadratic, I don't care what it is, the domain's always going to be all real numbers. So again, you're going to use set notation like this. In other words, it means the set of all x's such that x is an element of the real number system, aka it means all real numbers. I do want you to get in the habit, even if you're not in honors, to kind of get used to set notation. You'll be using it later on this year, but if you're not there yet, that's fine. Another option is to use interval notation, and that basically means that all real numbers implies that you want every value in the whole wide world, every real value. And so it would look like this, -infinity to infinity. And remember, with interval notation, the parentheses we always use around numbers that we either don't include, or in this case, because it's infinite, like it's not really an end, we use parentheses. If we were doing a stop and end, like we want only a specific number, we would use a bracket. All right, the range. If you haven't figured this part out yet, let's say this vertex is at the point, I don't know, 0, -9. So my range, again, that notation, you kind of start off with all real numbers. My range would be, my lowest y value here would be -9 on up. And so if you paid attention, it has to do with, in this case, y is greater than or equal to -9 would be how I would write my range. It has to do with the y value of your vertex. So that's that min or that max. So when you're writing the range, pay attention to the vertex, pay attention to the min or the max, and that's how you write your range. And then if you're going to do interval notation, your lowest, whoops, I got to put a bracket, your lowest, it always starts with your lowest number, comma, your highest number. So my lowest number is -9, and there's a square bracket here because I don't want to include, I want to include -9, but nothing past it. And then I want to go forever into the positives, and so I would use a parenthesis. Okay, I'm going to do a couple more examples for you just to kind of get you guys some practice. And then some of this stuff is stuff you're going to be doing in class as well. Let me go to page 33 of your student journals. All right, I'm going to do a couple of these. To do all of them, mostly because I just don't feel like it. Also because I want you guys to try some of these on your own. So I thought I'd do an example of each, maybe a vertex form, a standard form, and a factored form. So I'll do 2, 3, and I'll do 5. 2, 3, and 5. I'll do those 3 examples. Oops. All right. It says, label the vertex and axis of symmetry after you graph it. Find min or max, describe the domain and range of the function, and where the function increasing and decreasing. All right, this is a lot of stuff to put on this little piece of paper. So I'm going to do this on a separate sheet. You can squeeze it in here on this piece of paper if you so choose, but I'm going to do mine on a separate. All right, so if this is my function, I'm asked to find the vertex. I'm asked to find the axis of symmetry. I'm asked to find the min or max. And I'm asked to find the domain and range. So lots of information on one little piece of paper, one little example. All right, so let me show you how to do this. Vertex should be the easy part for a vertex form equation. The last thing I do is graph. So the vertex should be at the point 4, -5, because again, h, k. Got it. Axis of symmetry, remember what I said. It's always x equals the x value of your vertex. So in this case, x equals 4. All right, next, min or max. First of all, this graph is opening down. How do I know, you ask? Well, because there's a negative out in front. The a value is negative. So it's opening down, which implies it's a maximum. So you should circle min or max. So in other words, it's a max because my function is going to point down. You also need a value, which in this case is 2. Remember, we're talking about a distance here, so you wouldn't use the negative sign. So it's like the absolute value of a. Again, we're talking about the distance of, oops, and I lied. It's the y value of your vertex. So it's -5 on this case. So it's the y value of your vertex. And so it is a distance, but the negative kind of implies that we're moving down. It's like your lowest value on your, or highest value on your function. So again, simply just the y value of your vertex. I will do domain and range. Domain I can always do because it's the same for every single function. It's all real numbers, or you could write it in interval notation. Now to do the range, I like to graph it, but you don't have to. I just do. All right, 4, -5, looks like this. It's going to open down, and I'm just going to kind of sketch my graph so I know it's going to look like this. So put all the stuff in here that we found. So my axis of symmetry is a line that goes right through the center, and my min is at -5. That's the highest value. So that means my range would be any number -5 and lower. So y is less than or equal to -5. And that's what it would look like. So I just sketched it on this paper. I didn't graph it on the other one, which is okay. All right, number 3, this is your standard form equation. So y equals 3/2x squared minus 3x minus 1. All right, we're asked to find the same stuff. Vertex, axis of symmetry, min or max, domain, and range. Right. Easiest thing to find here is your y-intercept, which of course we didn't even ask you to find, which of course is -1. But all right, that's just an extra piece of information. All right, first thing I would do is find my vertex, after I already know my y-intercept, of course. So my vertex, you have to use that formula -b over 2a. b is already -3, so -3 would be +3. And 2 times 1.5 is 3. So 2 times 3 over 2 is 3. So I get an x value of my vertex to be 1. Pretty simple, right? Once you figure out the x value of your vertex, plug it back into your equation. So y equals, plug it in for x. So y equals 3/2 1 squared minus 3 times 1 minus 1. So this would be 1.5 minus 3 minus 1. So I get -2.5. If you like to write it as a decimal, that's fine. You write it as a fraction. I don't really care. Axis of symmetry is always x equals the x value of the vertex. I know this function is going to have a minimum because it's opening up, because my a value is positive. And so the minimum is going to be at -2.5. I know my range is all real numbers. I say that wrong. Your domain is all real numbers. And let's see here. My vertex is at 1, -2.5 is about right here. It's going to open up, something like this. It's going to have an axis of symmetry. And so my range is my range is going to be all real numbers. So this is at -2.5, so I want -2.5 on up. So y is greater than or equal to -2.5. And that would be your graph. All right, last but not least, the intercept form. Pick this one on purpose because this is the one that tends to throw people off. So f of x equals -7x and then x minus 6. Okay, you can tell the difference between vertex form and intercept form because this is not being squared. If it's in vertex form, the parenthesis is being squared. The other tidbit of information is that this is still a factor, even though it's not its own separate little parenthesis. We still factored out a -7x. So again, we're finding the same information. The vertex, the axis of symmetry, actually, this one asks for vertex axis of symmetry and your x-intercepts. Didn't ask for the rest of the stuff. So my x-intercepts are the easiest thing to find here because it's in intercept form. So take each of these and set it equal to 0. Those are each factors. So -7 equals -7x equals 0. Divide by -7. I get 0. Remember, this is an x-intercept, so write it as a point. X minus 6, set that factor equal to 0, and I get x to equal 6, which means that my point is 6, 0. All right, at this stage, I would go ahead and graph my function. It's going to open down. How do I know? Well, because it's the negative out in front. So remember, my a value is negative, so it's going to open down. This is the point 0, 0. This is the point 6, 0. Remember what I said about how to find the vertex. If it's already given to you in terms of you've already got the x-intercepts, the easiest way to find the vertex, it has to be halfway between your two x-intercepts. So what's halfway between 0 and 6? You get 3. So the x value of my vertex is 3. To figure out the y value, you go back up to your function. And essentially what you're doing is you're plugging in for x. So I get -21 times -3, a negative times a negative, I get 63. Yeah, this is definitely not going to fit on a normal looking graph, but that's okay. Unless I did something wrong, of course, which is entirely possible. All right, so this is the point 363. And those are my x-intercepts. I actually even drew the axis of symmetry in there, which is x equals the x value of your vertex. Okay, that's kind of a highlight of all three formats of your quadratics. I encourage you, you can do the extra problems on this practice page. So remember, I only did 2, 3, and 5. You can do the other ones to practice, and that way you any additional questions when you come see us in class, we can go over them. And then there will be a lesson, of course, on big ideas. All right, thanks everyone for tuning in.